Hello everyone, I'm Sebastian Y and this is Managerial Economics. In this video we're going to talk about how a monopolist maximizes profit if they have multiple plants. In the previous video we talked about a basic type of monopoly problem where a firm just has one plant, but now we're going to talk about monopolies that have multiple plants which each might have their own individual cost structure. To get a little notation out of the way, suppose that our monopolist has n plants, which we are going to denote as I. So I can be plant number 1, plant number 2, all the way up to plant n. Each plant, so for example, plant I produces Qi output. So plant 1 will produce Q1 output, plant 2 will produce Q2 output. These outputs could be the same as each other, but they definitely don't have to be. The total amount produced by the firm will be big Q equals all of these individual Qs added up. We're also going to assume that every plant produces an indistinguishable product from each other. So the consumer does not care which plant their goods came from. Previously, we maximized profit by setting marginal cost equal to marginal revenue. In principle, that is exactly what we're going to continue doing. But this time we have multiple marginal costs because we have multiple different plants. To maximize profit, we're going to produce the quantities such that the marginal revenue equals the marginal cost at plant 1, producing Q1, equals the marginal cost at plant 2, producing Q2, equals all of the other marginal costs at all of the other plants all the way up to plant N. Note that I'm putting the total quantity, big Q, inside of the marginal revenue function. This is because the consumers cannot tell and do not care which plant their goods came from. So once we get the goods to the market, we're dealing with big Q, all of the little q's added up. So when you're doing this, make sure to take all of these and plug them in right here. Just like with the basic monopoly problem, we can also do this by setting up our firm's profit function and taking the first order conditions, that is, taking each of the partial derivatives with respect to each of the quantities and setting all of those equal to 0, and then solving this as a system of equations. You'll get the exact same answer. Throughout this video, I'm going to show you both methods. You can do whichever one you are more comfortable with. Before we move on to an example, I want to point out that if every single plant has the exact same cost function and the exact same cost structure, then every plant is going to produce the same quantity. In that special case, we're going to have Q1 equals Q2 equals all the way out to Qn, which is going to be big Q divided by n. However, if the cost structures are not the same, this will not be the case. So for example, suppose that we had two plants that have different marginal costs. So in plant 1, let's say our marginal cost curve looks like this, and in plant 2, our marginal cost curve looks like this. So in this example, plant 2 generally has a lower marginal cost than plant 1. We know that to maximize profit, the marginal cost in each plant is going to end up being the same. And so if I draw a horizontal dotted line across our graph, in the end, we know that the plant that has the lower cost generally is going to end up producing a higher quantity than the plant that has the higher cost. And that intuitively makes sense. A firm is going to make more use of its more efficient plants. When we get into our example, we will show this mathematically. Let's get into our example. Suppose we have a demand function, QD of P equals 100 minus P. The monopolist has two plants. In plant 1, C1 of Q1 is our cost function, which is Q1 squared. In our second plant, we have a cost function of C2 of Q2 equals 2Q1 squared. Our firm's total output is going to be Q equals Q1 plus Q2. As with any kind of monopoly problem, the first step is to solve for the inverse demand function. So we're going to take our demand function and we're going to solve it for P. If I add P to both sides, I get P plus Q equals 100, and then subtract Q from both sides, I'm going to get my inverse demand function P of Q equals 100 minus Q. Since the slope is 1, I did not have to divide this by anything, but you might have to in one of your problems. Next, I'm going to find the marginal revenue function. I could use calculus to find this, but it's totally fine to use the shortcut of doubling the slope for a linear demand function. Note that I have doubled the slope of the inverse demand function, not the original demand function. Be very careful about that. Next, I'm going to find the two marginal cost functions. So working from my cost functions, starting with the marginal cost for plant 1, I'm going to take the derivative of our first cost function, and that's 2q1. And for our second marginal cost, I'll take the derivative of the second cost function, which was supposed to have said q2 right in here. So we're going to get 4q2. To maximize profit, I'm going to set the marginal revenue equal to each of the marginal costs and solve that as a system of equations. Before moving on, I'm going to rewrite our marginal revenue function to plug in this equation right here. So we're going to get marginal revenue equals 100 minus 2 times Q1 plus Q2. Just to simplify things down, I'm going to distribute the 2. So 100 minus 2Q1 minus 2Q2. Do not forget to distribute the minus sign to both terms here. For our system of equations, I'm going to take our marginal revenue, 100 minus 2Q1 minus 2Q2, and set that equal to our first marginal cost, which is 2Q1. And for our second equation, I'm going to do the same thing, but I'm going to set it equal to our second marginal cost function, 4Q2. Now we'll go ahead and solve this. There's many ways to go about this, but what I will do is take our first equation right here and solve this for Q1. So I'm going to add 2Q1 to both sides, and that's going to give me 100 minus 2Q2 equals 4Q1, and then divide both sides by 4. So I'll get 25 minus Q2 over 2 equals Q1. Now that I have solved this for Q1, I'm going to plug that in to our second equation wherever I see a Q1, which is right here. So that's going to give me 100 minus 2, but where I had Q1, I'm going to write 25 minus Q2 over 2, and then continue on with the rest of the equation. I now have an equation that just has a Q2 in it. We'll continue this carefully doing the algebra, so we're going to have 100 minus 50. Now the minus 2 and the minus 1/2 are going to completely cancel out to plus Q2 minus 2Q2 equals 4Q2. 100 minus 50 is 50. And then I have a plus Q2 and a minus Q2, so that's going to resolve to minus Q2. Then I'll add the Q2 to both sides, and then divide both sides by 5. That's going to give me Q2 equals 10. I'm going to put a subscript M up there just to denote that that's our monopoly's profit maximizing quantity. To finish this thing off, I'm just going to plug that Q2 right into this equation right here. So I'm going to get Q1 equals 25 minus 10 over 5, which is going to be 20. So I'll write Q1M equals 20. Plant 1 is producing more than plant 2, and if we compare the marginal costs for each plant, the marginal cost for plant 1 was 2Q1, the marginal cost for plant 2 was 4Q2. So the high-cost plant ends up producing less output than the low-cost plant. I'm now going to show how to do this exact same problem, but with the profit function and first-order condition method. It should give us the exact same answer. To do that, I'm going to set up a profit function, pi of Q1 and Q2. And I'm going to set this up as total revenue minus total cost. Our inverse demand is P of Q equals 100 minus Q, which we can then write as 100 minus Q1 minus Q2. We want to make this entire problem in terms of our individual plant quantities. We also had our individual cost functions, which were C1 is Q1 squared, and C2 was 2Q2 squared. So our total revenue is going to be price of 100 minus Q1 minus Q2 times our total quantity, which is Q1 plus Q2, minus Q1 squared minus 2Q2 squared. I'm going to collect terms on this thing to clean this up a bit. First, I'm going to take Q1 and distribute that across this entire function on the left, 100 Q1 minus Q1 squared minus Q1 Q2. And I'm going to do the same thing with the Q2. So we're going to get plus 100 Q2 minus Q1 Q2 minus Q2 squared. And then that leaves us with our costs minus Q1 squared minus 2Q2 squared. Next thing is I'm going to collect terms. So I've got 100 Q1 plus 100 Q2. So that takes care of this and this. For the cross multiplied terms, I've got Q1 Q2, Q1 Q2. So that's going to add up to minus 2 Q1 Q2. For the Q1 squareds, I got two of those right here, so minus 2 Q1 squared. And then for the Q2 squareds, I've got one here and I've got two here, so minus 3 Q2 squared. So once we collect terms, this thing doesn't look quite as bad. Now I'm going to take our first order conditions, and we have two of those this time. So I'm going to use a partial derivative of the profit with respect to Q1, and then I'm going to do the same thing for the partial derivative with respect to Q2. For Q1, first term, we've got 100. Second term, there's no Q1 in that. That drops out. Third term, minus 2Q2. For the fourth term here, we've got 4Q1. And our final term here does not have any Q1s in it. Set this equal to 0. For the second one, I'm going to do the exact same thing, but this time with respect to Q2. We get 100 minus 2Q1 this time. And then minus 6Q2 equals 0. From here, we would solve this as a system of equations, and we would get the exact same answers. These two first-order conditions are exactly the same as our two profit-maximizing conditions that we used earlier. If we go back up here, notice that if I were to subtract 2Q21 from both sides, that would become minus 4Q1. If I subtracted 4Q2 from both sides over here, this would become minus 6Q2 with a 0 on the right-hand side. Exact same equations, exact same solutions. So it does not matter which method you use here. Whichever way you go about this, we're going to end up with Q1m equals 20 and Q2m equals 10. To figure out the price, we're going to plug that into our inverse demand function, which was 100 minus Q. So we're going to take both of those Q's off there, which is going to give us 70. And to calculate the profit, we have a revenue of 70 times a total quantity of 30 minus our cost at each plant. At our first plant, we have Q1 squared, so 20 squared. At our second plant, we had 2 Q2 squared, so 2 times 10 squared. We're going to end up with 2100 minus 400 minus 2 times 100, which is 200, which is going to come out to 1500. And that is how we maximize profit when we have a monopoly with multiple plants. That is where we will leave it for this topic. If you have any questions, feel free to let me know. Thanks for watching.